So we now define group law on elliptic curves. So say you have elliptic curve x. On this elliptic curve, the group law will be given by this pick group. So notice there is a 0 here. So this is a pick 0 group. So this is not a general pick group, but a pick 0 group. And this is defined as equal to divisors, 0 divisors, modulo out the principal divisors. So for an elliptic curve x, and you have a special point P0, you can call this origin. You can consider the following map. This P gets mapped to P minus P0. So notice that P minus P0 is a 0 divisor. So this is 1 P minus 1 P0. So 1 minus 1, when you add 1 and minus 1, you get 0. So this is 0 divisor. Notice that this does not lie in principal divisors for elliptic curve x. So in the last lecture, we saw this lemma in which we saw that if genus is greater or equal to 1, these 2 points, say P which is not equal to P0, then P minus P0 does not come from a divisor of a function. So this we saw in the previous lecture. So therefore this makes sense as a group. So divisor 0 modulo out the principal divisors, and this does not lie in the principal divisors. And anyway, it's a 0 divisor because 1 minus 1 is 0. So this map gives 1-to-1 correspondence between points on the elliptic curve and the elements of the pick group. So you just take a point on the curve, and to it you attach this divisor which is equal to P minus P0. Obviously this degree of D is 0. So this is 1-to-1 correspondence, and this PO we are calling as origin. So in the previous lecture we saw that for an elliptic curve from Riemann-Roch, it followed that L of D, the dimension, is equal to degree of D. So if degree of D is 0, then you get degree of D plus origin is 1. So therefore there is a unique effective divisor which is linearly equivalent to D plus P0, and it is generated by a single point P because degree 1, so it has to be generated by a single point P, something like this. So P is equivalent to D plus P0, which implies the divisor is nothing but P minus P0. So essentially what is being said here. So you get the correspondence, and the group law precisely follows from addition on these divisor 0. So you take divisor 0, so any divisor which lies in this, and you add coordinate wise, you will again get divisor 0, and so on. So because divisor 0 itself is a group, this pick 0 is a subgroup, and all the addition laws it inherits from divisor 0. So this is an easy way to see the group law on elliptic curve. So you have seen group law on elliptic curve. Now there is a more involved way where you draw chords and tangents, and that you can find in any book on elliptic curves, but this is an easy way to see it using Riemann-Roch.